Hi, welcome to this lesson on calculus. What is the derivative? Let's have a look at deriving from first principles, question 4. So again, the first derivative, f prime x, is defined as the limit as h approaches 0 of the average gradient formula, f of x plus h minus f of x, all over h. So I'm going to do my algebraic gymnastics on the side and then substitute in. So first of all, my f of x is equal to x cubed. So f of x plus h, so wherever there's x's, I must now replace it with x plus h. So it's going to be x plus h all cubed. Okay, but we can expand that out. That is x plus h times itself 3 times. Okay, so now if we do that, let's expand these first two brackets. X squared will have plus xh, so two amounts of xh, plus h squared times x plus h. Okay, now we need to expand again. So x squared times x is x cubed, plus x squared h. Then we're going to have plus 2x squared h, plus 2xh squared. And then lastly, plus h squared x, plus h cubed. So again, lots of algebraic gymnastics. Make sure that we collect and expand the terms correctly. All right, so I'm going to leave it like that for now and then just evaluate that difference. So what's that difference? That is f of x plus h minus f of x. So that's equal to x cubed plus x squared h plus 2x squared h plus 2xh squared plus h squared x plus h cubed, all minus x cubed. Okay, so that's nice, only one term for f of x. So the x cubed will cancel with the x cubed. And notice that there are h terms everywhere in the expression. So if I pull out a common factor of h, I'm left with x squared plus 2x squared plus 2xh plus x times h, or h times x, plus h squared. Okay, so let's go ahead and put that in there. So we have equals to the limit as h approaches 0 of h times, so x squared plus 2x squared, that's 3x squared. Okay, 2xh plus xh, that's 3xh. And then plus h squared, all over h. Now, these h's will cancel from each other in the numerator and denominator, and we're left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. So you can see you've got to keep writing that limit notation until you evaluate the limit, which is what we're going to do now. So it becomes 3x squared plus 3x times 0 plus 0 squared. So now that just leaves you with 3x squared. So again, notice the pattern. We started off with x cubed, and now we've got a 3x squared. So we went from a cubed term to a quadratic term, a third degree polynomial to a second degree polynomial. Okay, and it's almost funny. You can see the 3 in the exponent is now here as a base coefficient, and it almost looks like the power of 3 just went down by 1. And that's no coincidence. That is actually the power law for derivatives. And again, we will note that when we do the derivative laws. All right, so that's how we would solve this type of question. I'll see you in the next one.